Hello, my name is Mohsen from Seoul National University. I'm glad to introduce our paper, which has been published in CVPR 2024. The title of our paper is CNC-Net Self-Supervised Learning for CNC Machining Operations. Computer Numerical Control, or shortly CNC, is a computer-based system used to control various machining tools such as drills and mills. It operates using pre-programmed instructions such as G-code or M-code to shape materials in the desired shape. These instructions include a sequence of operations that can be created by expert machinist programmers. In this study, we only consider CNC machines that use milling and drilling processes applied from the top of the workpiece and include rotation capability. First, we introduce the component of a generic CNC machine and model them mathematically for further processes. Let's consider S as a target shape to be produced. We model the input material that should be carved as the bounding box of the target shape. Without loss of generality, we model milling and drilling tools using the implicit form of cylindrical primitives. The milling tool can move along a specified path to carve or cut through the material, so we represent the path using a parametric function. Accordingly, we can implicitly represent each CNC operation. Milling is the process of removing material from the workpiece using rotating cutting tool. The milling operation at the step S can be defined as the process of a tool traversing a path. Drilling is a machining process that uses a rotating drilling bit to create holes with a specific size and depth in the workpiece. The drilling tool at the step S penetrates a designated location and can be simply represented. CNC machines are equipped with the ability to rotate the workpiece at different angles. We assume that the machine can rotate the shape at the step S by a rotation transformation parameterized by the angles. To learn CNC operation in a supervised manner, having a label is crucial. However, the complex exercise space for operation involving NP hard programming labeling optimal solution as ground truth. Therefore, self-supervised learning provides an alternative approach for finding the appropriate operations to form the target shape. Accordingly, we propose a self-supervised method named CNC-Net that can produce a target shape from the input material by learning the CNC operations. We start with making the bounding box of a target shape and then voxelize it. An encoder receives the voxel and encodes the features, then the encoded features along with the voxel size of the bounding box passes through a LSTM model to generate the features, which are then fed to a path decoder to generate the path, the radius decoder to generate the radius of the tool, and to the rotation decoder to generate the rotation angles. Given the path and tool radius, we can make the milling operation, and with the angles, we can construct the rotation matrix. The generated operation and the rotation matrix, along with the shape at previous step, go to the CSG operation to generate the shape at the current step. In the next slide, we will introduce the CSG operation in details. Given the shape at previous step, the shape is rotated by the corresponding rotation matrix. Then milling or drilling operation is employed from the top of the workpiece, and the results of their subtraction passes through the inverse rotation to ensure that its orientation matches the initial orientation. We iteratively perform milling operation for m steps until no further improvement is achieved. After completing the milling operations, we proceed with the drilling operation in a similar manner. The shape generated from the milling serves as the initial material for drilling, and we iterate over these steps until a significant similarity is achieved. We focus on reconstructing the target shape by autonomously generating the necessary operation in a self-supervised manner by defining a set of loss functions to reproduce the 3D models. The model is initially trained on whole objects and is then fine-tuned for each object individually. The milling loss ensures that the implicit shape obtained through sequential milling operations accurately approximate the target shape. The drilling loss facilitates the drilling operations to remove the remaining regions after the sequential milling operations. The shape loss ensures that the regions inside the target shapes are not removed by any milling or drilling operations. The center loss simplifies the training process by narrowing down the search space for the generation of the tool coordinates. We show the learned path for 4 steps and the generated shape after applying the milling operations. The results indicate that the model generates an initial path outlining the boundary of the target objects to form its overall shapes, followed by shorter paths in later steps to capture finer details. We compare our method to Meshcam, a standard tool for CNC machines. Meshcam typically carves dense paths layer by layer, while our method offers more flexible carving actions, resulting in producing tools paths averaging 13 times shorter than those generated by Meshcam. We fairly compare our method with 3D shape reconstruction methods under the same setups. The results illustrate the superior performance of our self-supervised method in accurately reproducing target 3D models by simulating CNC machining operations. Thank you very much for listening. Our code and the pre-trained models are available at GitHub.